Yeah, so then we'll discuss how to do georeferencing on QGIS, which will be very important for this main mapping project. And then I guess, so Thursday or tomorrow your homework is due, and we'll discuss it on Thursday. And Rich wanted to discuss some examples mapping from students. Do you want them to send me shapefiles or just the screenshots that they turn in?
Yeah, I think, well, either way, we'll work with whatever. But if you do have a shapefile, that'd be great. Just send it to Chelsea, and then maybe you could have it up on QGIS on the screen as we're talking.
So if you send me the shapefile, though, the computer makes a bunch of auxiliary files that go with the shapefile. So for me to be able to open it, you have to send the whole set of files. So yeah, send those around the same time that you submit your homework, and then I'll be able to show them in class. And then for the rest of Thursday, Tim will discuss different mapping conventions that you will use for the project. And again, it's a good time to really pay attention and be ready to ask questions. And then next Tuesday, we have a very special class where we have Jessica Thompson and Bill Ferozden, who are going to be talking about their pre-rupture mapping for the Ridgecrest earthquake. And so in advance, I'll put their paper on our course website, and you'll do the typical reading drill of summarizing and asking some questions that you should be ready to ask in class. And around then, I will send you the actual area that you're going to map, as well as how to access data sets. And then on Thursday next week, we'll have a little bit of a normal class, and then the rest of the class will be for you to ask questions about starting your mapping project, in other words, how to get data, or any clarifying points. Are there any questions? Comments? All right, so let me share my screen. Okay, so let's see. My email. So here's the course webpage, and if you go to schedule, if you come down today, September 22, you'll see discuss main mapping project and the handout. So I'll be discussing this handout today. So feel free to grab it or just watch along on the screen. Okay, so this handout, so main mapping assignments. So over the course of the semester, so far, we've been discussing approaches for mapping, both using morphometric approach as well as mapping geomorphology. And the idea of the rest of the semester is that you will apply what you've learned from those assignments to mapping about 2 different faults. And the idea is that our colleagues who've been hearing from the semester will use these fault maps to understand fault displacement, the probabilistic fault displacement hazard, or as we abbreviate, PUFDA. So our plan is to write a peer-reviewed manuscript based on the mapping that you do, as well as some of the science that we can then gain from these maps. And students who complete the mapping assignments will be co-authors on the paper. So that's some motivation for doing this assignment well. So each student will have 2 mapping assignments. The first one we'll do in the next 5 weeks, and the later one will be in the final 5 weeks of the course. And we expect you to spend an average of 4 hours each week on the mapping. So that's 20 hours total. And we'll help you pick an area so that you can really make a good progress in that amount of time. And so it's much more important that you produce high quality and well-documented mapping over a small area than you have lower quality mapping over a larger portion. So this is not a race, to be clear, between students to see who can do more mapping. And certainly the challenge and the progress that you make will depend on the location as well as the data sets that you have.
And if I can just add there, Chelsea, I think this is kind of interesting for you guys, but it might be slightly unusual in the sense that it's a pretty large project, but it's also one that we have an expectation of you kind of working steadily on. So, if you're like me, you probably usually sort of do work in sort of binge mode where you kind of pull an all-nighter and get it all done at the last minute. But this needs to be done really more steadily, and we're going to kind of trust you. And as Chelsea will say, we'll have some check-ins as we go. So you got to keep up. But the idea is also that you kind of find a way to get yourself to do as we recommend, which is not less, but also not more than 20 hours. So we can tell if you're doing less because it'll just be clear that not enough work got done. But you don't need to overdo it. You don't need to do more than 20 hours because it's part of this kind of overall experiment that we kind of have some control, some sense of the level of effort. And there's lots of things like early on when we planned the course, we asked various colleagues, some, who are here, and you guys remember Steve Thompson, how long does it take to map a kilometer of fault? And so we need you guys to, again, lots of these little things will help us with kind of the compilation synthesis that happens at the end. So I just wanted to take a break to interrupt you, Chelsea, to help emphasize this kind of level of effort as being kind of serious, not just some notional concept, but we need you to basically do what we're asking, but we're not going to check. So you just time yourself and do it and keep it up.
And it's important that you do the 4 hours each week and don't wait to the end to do the 20 hours. So yeah, we'll get more on some progress checks later. So as you'll see in the PowerPoint that I sent out, there's a list of earthquakes as well as the data sets that are available for those earthquakes. So we can talk about that in more detail in a little bit. But so we'd like you to pick your top 3 choices of areas to map and then send those to me. And we will plan to give everyone at least one of their top 3 choices in either the first or the second mapping period. And so to be clear, these data sets that are on the document on PowerPoint, these earthquakes have pre-earthquake data. And so you are going to just be mapping from the pre-earthquake data. And as you'll see later, we'll discuss that you should avoid all temptation to look at any post-earthquake data. Are there any questions so far? Okay, so here's a discussion of what you should include in your mapping. And some of these features we'll discuss in a little bit more detail, particularly the mapping conventions throughout the next week or so. But if you have any questions now, please ask. So at the beginning, we ask you to pick an area that's reasonably small and to spend 2 hours or so doing a detailed mapping. So that will be at the level that you've been doing the either morphometric or geomorphic mapping. And it's your choice to pick which form of mapping is appropriate. And again, it will probably depend on what data sets you have available. And so you should create a legend or an explanation that describes your mapping notation and the units that you do. So again, very similar to the homeworks that you've been working on. And then once you complete those 2 hours, it's up to you if you think that the very high level of detail is important for your mapping, or if you think you've gained enough context to the landscape that you can focus on just mapping the faults. So when you're mapping the faults, we expect you to use a shapefile. Again, if you have any issues with QGIS, please don't hesitate to get in touch. And when you map the faults, you want to have attributes that include information such as what data set you used to make the observation, quality ranking, and if the fault is primary versus secondary. And of course, you may find other features that you would like to make comments on. And so perhaps you want an extra comment section where you can write notes about the faults. And so it's very important that when you're done, you have a nice and complete shapefile that contains this faulting information, because that's what we're going to use in the subsequent work based on your mapping. So you'll want to use a develop a numerical scale to rank your mapping. And at the very least, you could use something like this, where 4 is strong based on their evidence in the different data sets that you have. 3 is distinct, 2 is weak, 1 is concealed. And in your report, you should have a description of what each of these characteristics mean for your landscape or for your data set. And we expect that you'll have a slightly different description of what either tectonic or geomorphic properties indicate each of these 4 different quality rankings in different types of landscapes. So you want to note primary versus secondary. And we haven't talked too much about this yet, but either this Thursday or next Thursday, we'll give you and discuss a document with several examples showing how to denote if features are primary or secondary. So we'll leave these two to discuss in more detail later. And finally, if there's anything else appropriate for the landscape or the fault that you're mapping, you're in charge, so add it to your map. Are there any questions on this first part? This middle part, I guess. Nope.
Yes, Chelsea, I'll just add one quick comment. This is Rich on the first part, where you're mapping like a test area and trying to figure out the scale that you're going to map at. Zoom in, zoom out a little bit and explore around the landscape a little bit. You're going to want to map some geomorphic surfaces and then zoom out and see if you can see those surfaces in other areas. If you zoom too far out, you're not going to be able to see some of the small units you've mapped. If you zoom too far in, it doesn't give you a good perspective. So you just want to play with the scale a little bit, do a little bit of mapping, zoom in and out, see if that's looking like it's going to work. And then that'll also give you perspective when you look at other areas along the fault trace to start understanding the geomorphology and where the faults might be.
One thing just to add in there, I think what Rich is saying is a really good suggestion. The other thing I say, and maybe some people who took the field class with me remember, is with respect to scale, what's kind of weird is that I always think like you want to have one observation every thumb width on the entire map. So, you know, it's like every centimeter you have to look and you check. You're like, okay, is there anything here? And if there's nothing, it's still something. You need to, you know, sort of indicate that you look there, check, you know, maybe detail on the boundary line of a polygon, but you're very thorough. But the point is, kind of what's fixed is the sampling across the screen or the piece of paper. So obviously, if you zoom in, what you're sampling is bigger in real life, and if you zoom out, what you're sampling is less. So that those two things going together is sort of the sampling detail relative to the scale is something to keep in mind, but also just really have a sense of being thorough. Obviously emphasizing the zone of interest, but go to the edges, don't miss anything. I feel like it's psychologically important when you map that you're sort of engaged in that sense, where you're really sort of getting in your mode of mapping and covering the ground in a sort of systematic way. And that's why you need the time. Another thing, just another piece of advice here, which will feed into what Chelsea's going to present next, is I would suggest kind of just like if you're mapping in the field, you have a notebook. So kind of log what you do. Just write down, okay, so today's Tuesday, 10 o'clock, I started working, you know, it took 15 minutes to get started. I had to go get a coffee because I still wasn't motivated. But by 10:20, I got working. And here's kind of what I did. I made some decisions. Here's my map units. And just use that as part of your routine or your way of engaging with the work, but also documenting what you've done. Because, you know, if it's 5 weeks, you might forget. You're like, crap, what was I thinking, you know, a month ago? So I think it's worth giving yourself that sort of routine and structure, and it'll feel better, I think. And then when you have to report, you'll have something to draw from.
And you can keep track of those notes with the point coverage on your, you know, on your electronic file. And you don't necessarily have to turn in that point coverage with your final map, but you can put notes associated with everywhere you've looked by just clicking a point and adding some notes. And it's a good way to archive it.
Oh, that's an excellent idea.
Yes, thank you. Are there any questions from students? Well, it's so quiet today. All right, so as we were discussing a few minutes ago, it's important that you are continuously working to make progress, work about 4 hours a week on this project. And to help you make progress, we are going to have progress checks. And so every Thursday, we'll spend about the first half of class discussing the mapping project. And each student will present their progress every other week. So when you present, this week is assigned to you, you'll want to prepare a 2 to 3 slide presentation showing work you've been doing on your mapping. So an area where you're making good progress and you're happy with how things look. And then an area where you have a question or you're a little bit less sure about how to proceed. And so when you make these slides, we don't want you to be hesitant about showing areas where you're a little bit uncertain about what you're doing. And really think that you and your classmates will benefit from the discussion that comes from areas where you have questions. And so we'll plan to spend about 5 minutes discussing each person's mapping after they make their short presentation. And finally, if you have questions, please don't hesitate to get in touch with us. So this is really a research project. It's different than many class projects where we know the answer. We don't know the answer. That's why you're doing it. And we also cannot anticipate every single question that you'll have in advance. So please come talk to us. You can email us, come to office hours, which we'll still have. if you have questions, but we don't want you just sitting wasting time because you don't know what to do or you don't know how to find the data set. There are questions?
I guess there'll be certainly times where you're just staring at the screen and you don't see any faults and you don't know what to do, and that's when the questions should start coming, you know, and then we can start thinking about, oh, do we want to do some more like quaternary mapping, or do we want to do some more morpho mapping, or what's going to be appropriate in this area to really kind of start to try to figure it out, you know? Because we all have those moments where we're just like, I don't know where it went. Where do I map it here? I'm not sure, you know, and you have to bring in all the tools to start searching.
Yeah, and Steve Thompson agreed with my point. He says he's supporting the idea of, you know, map systematically and document at minimum regular intervals, knowing that a mapper looked and did not see anything or any feature suggested of faulting is as valuable as documenting feature suggested of faulting. So yeah, so just that's why I like this thumb. I was like, I'm gonna go across the entire map, at least every thumb I'm gonna look and you know, go from there. And then I really like Rich's idea of tagging those points, and like we had one time. I'll tell a small story just to help break up the lecture, but we were mapping on the San Andreas once with one of my former students, Elizabeth Stone, and we got to a part of the San Andreas and we were mapping, and we couldn't figure out what was going on. There's lots of drainages along the fault zone, and so Beth was getting really frustrated. So we started calling that area the NFC area, which crudely was no frickin' clue, but we decided to call it no fault conspicuous. So we tagged that part of the map as NFC. But my point is just, we didn't know. It was like totally annoying piece of the fault zone. Even though 35 millimeters a year of slip goes through there, it was very discontinuous. So we just had to sort of stamp it NFC, NFC, NFC. And then on either side, we could then get back to understand what's going on. So in that zone of NFC, what we figured out was that there's a bunch of small faults that were sort of chopping the fault zone up, and a whole bunch of blocks are kind of going up and down. And if you remember from our lectures about strike slip, it was kind of like a flower structure, but a very discontinuous flower structure. So anyway, when you're frustrated, you can say no frickin' clue or something worse, but you might clean it up in the end and just say no fault conspicuous.
Yeah, and on that front, I've tried to note on homeworks where people leave blanks, and in a few cases, you've actually left blank the key areas. And so it can be very dangerous to leave an area blank. So even if you don't think it's very important, at least try to map something, or at least have some description of what the landscape is doing, or why you don't think it's showing anything interesting. And as you're just trying to show that, you might find something that's important.
I mean, even simple things like slopes and stuff like that. It's steeper here, it's shallower here, things like that can provide clues. So you can use the profile tool that we'll talk about Thursday, and that is part of the homework, to just sort of get an idea of what the slopes are looking like, perpendicular sort of to the strike of the fault you're mapping and stuff like that.
All right, so now move on, talk about some guidelines. So when we assign you a particular fault/earthquake, we'll send you the data sets that we found that are available for that area. And of course, it's not impossible that we've missed some good examples of pre-earthquake data sets. So if you know of any, for example, or you don't spend really any time searching, but say you find some, then please speak to us in advance before you start using those data sets, because we do have some specific rules about data sets we either do or don't want you to use. For example, we don't want you to use geologic maps. It's a very important rule. Do not look at post-earthquake imagery, including base maps in GIS programs, as this will completely defeat the point of the exercise. It's not necessary, and we'll probably know from your results. So it's a very important part of the assignment. We're going to ask that you do not research the earthquake. Again, it's important that you remain unbiased by any specific observations from that earthquake. And if you want to know something you think is important for mapping the fault zone before that earthquake, please speak to us and we can probably help you. At least get you the answer that you need if we agree with you that it's important for the mapping. Another important point is that you must work individually. In class, we'll discuss mapping, and so you will see and benefit from discussions that your classmates bring up. But for the purposes of the mapping, we expect that different mappers will map differently from an individual data set, and it's very important that we capture these differences. And so some data sets that we'll give you are publicly available. Some of these will actually ask you to go and download yourselves. Others of these data sets, which I've noted on the PowerPoint, colleagues have shared with us prior to the publication of their data set, under the expectation and the agreement, sometimes signed agreement, that we will not share the data sets beyond this class. And so just very clear, don't share any of the data that we give you.
Yeah, and if I can just add, just to talk a little bit about this idea of not researching the earthquakes themselves. You know, it's natural for you as a student. You're like, well, I'm trying to figure this thing out. I'm just going to look it up. And so that's a good thing in general. But this is, we don't want you to do it. You can't do it. Because this is a really special situation where you guys are inexperienced. And so in that sense, you're kind of a fresh piece of clay and you don't have a whole bunch of biases. So, you know, there's two kinds of biases we want to avoid. One's called an anchoring bias, and that's failure to depart from initial ideas. But the other one would be a confirmation bias. And this is one that experts suffer from. And that's where we actively seek facts to support our own hypothesis. And so we do it all the time, but you guys we have a special situation where you guys don't necessarily know much about these events. And so it's a more pure, and we would argue, hopefully unbiased effort to characterize these fault zones. So in that sense, you guys should feel special. You're unpoisoned by other knowledge, and so let's keep it that way. So so try to really protect yourselves. Don't worry that you might not be finding anything. That's okay, because we want to see what you can figure out using these principles that we've been discussing. So that's just another speech to help emphasize this point.
Are there any questions from students? Everyone understands? Perfect.
Yeah, no, not so far. Pretty clear.
Yeah, I'm really good. I have a question, but it pertains to the locations, but that can wait till later.
Okay. So data sets. So for your particular assignment, we'll indicate to you exactly where to get the relevant data that you need. Common sources will be USGS, which you explored in your most recent homework assignments. You look at Google Earth, and I'll show you later today how to use the clock button to get older imagery. And when you're looking through this older imagery, so the SCUTs, it's important that you scan through data sets to find the best ones that have the high resolution. And this is particularly true in non-urban areas where there's many older data sets that look relatively blurry compared to ones that are taken either right before or right after them. So another source you'll want to look at is open topography, which Ramona and I are very familiar with. And this is largely a resource of LiDAR and stereo satellite topography data sets. And so for a few of the projects, there's key data sets that you'll get from this resource. And for some areas, we'll give you, purely for larger earthquakes, we'll give you a shapefile indicating regions where you should concentrate your mapping. And so if it's not in the shapefile, we basically don't want you to map there, because we're reassigning areas that we think are reasonable to complete in the 20-hour time limit that we're giving you. Are there any questions? Okay, so for each of the 2 areas that you'll map, you'll want to generate a report. And so here we go over what are the important parts of this report. So we want you to have a short paragraph that describes the tectonic setting and climate of the area. Again, we don't want you to look at specific information from the particular earthquake. So you could even start with Wikipedia, try to find some resources in there, or in Google Scholar, or sometimes find general overviews of a tectonic plate, tectonic plate boundary that don't go into specific details about the earthquake that you're looking at the pre-earthquake data for.
So maybe not even the particular fault. So papers that don't go into the earthquake, but maybe not even talk about a particular fault in general, but just sort of regional papers on regional tectonic setting. We can help you sort of find some of those.
Yeah, so for example, if we're looking at Seattle area, you would definitely want to know that there's a subduction zone environment, and research briefly that the glacial past was important for the geomorphology that you're looking at.
Yeah, it's something to be cautious of, that you could inadvertently poison yourself if you stumble across information about the earthquake. So just if you see it coming, look away. Just try to be disciplined.
So then you want to have a section on the data sets that you're using. So you want to include basic metadata, such as what is the type of data that you're using, what is its resolution, and the acquisition date. If you have multiple data sets, you could show this information on the table. And then finally, you'll want to address what specific qualities of the data set that either helped or hindered your mapping. And this could be particularly interesting if you're looking at data sets that were acquired at different time periods, because you'll likely see differences in resolution, or maybe you're working with some air photos and a digital elevation model. So this is an area where you can discuss which data sets were useful for making different types of observations. So in the next part, you'll want to show the full line work of your mapping and discuss the following components. So for the beginning part of the map, you'll show the morphology and or the geomorphology that you mapped with a good explanation of your mapping units. You'll want to very clear shapefile. Could be called faults, where you really the main product of your mapping. For each of the faults, you'll want to have a quality ranking. Again, we talked before, use this 1 to 4 ranking scale or develop your own. But either way, you will want a very clear description of what properties in the landscape and the fault you used to rank each of the faults. You'll want to indicate if features or faults are primary or secondary. The maps that you made should have a scale bar, legend, north arrow, and a caption. And last week, John showed us how to make very nice map output from QGIS. So thank you, John. And I guess also importantly is your description should include the coordinate reference system that you use to save all of your line work. And then the final part of your report is you'll want to pick 3 areas that you thought were particularly interesting, and you'll want to zoom in of each of those areas and discuss what you see, what you thought was interesting. For example, areas that have different quality rankings, areas that have, for example, only primary faults, or areas that have both primary and secondary faults. And we want you to highlight areas that perhaps some that you thought were relatively easy to map, but then some that you thought were challenging. And finally, so for each area, you'll want to have a figure, this caption, scale bar, legend, north arrow, etc., and then about half a page of text describing why you think this area is important, worth discussing. Are there any questions?
CJ was just asking, is it a total of 20 hours for both or 20 hours each? And it's 20 hours each, so 2x 20 equals 40 over 10 weeks.
Yes.
And then we'll be presenting stuff to the class. Each student will be presenting, observations on Thursdays. What is the plan for Tuesdays once we get deep into the final project weeks? Are those like work days, or how are we working on that?
So Tuesdays, once we get going, we will be discussing papers on Tuesday.
Discussing papers. Okay, yeah, I'm sorry, I forgot that part, but.
So yeah, papers are discussing, or Tuesdays for discussing papers, although we may not start that immediately. And then the rest of Thursdays, we'll probably have a brief lecture for the rest of the half an hour, 15 minutes, on smaller topics such as different data sets that you're using.
So essentially, it's 4 hours of work at home per week on each project. And when you're presenting on Thursday, you can kind of think of that as a time to discuss with us and your colleagues a little bit and kind of focus your home work.
Yes, the class meetings don't count as the 4 hours each week.
Yep. Yeah, I'm just trying to clarify that for the students. So.
Are there any questions?
Not so far.
Did anyone have questions on the the PowerPoint. Trying to find it to show.
Yeah, good idea.
I have a quick question. For the point cloud from air photos, will we be able to extract any of that data into like hillshade data?
Yes.
Stuff like that?
So for that, I will make a DEM for you, so that you'll still be able to make all the products that we've been making from the DTM, for example, that you looked at in Seattle and now Nevada.
So just to remind everybody, you're picking how many of these and letting Chelsea know?
So you're picking 3.
Prioritized.
That you would, yes. And then the idea is that, assuming everyone doesn't pick the exact same 3, that you will map, at least one of your projects will be one of those 2. Or sorry, one of those 3. And it may be the second 5 weeks. So the first part, you may not map the area that you are most interested in.
I'm not sure you said it, maybe you did, Chelsea, but the idea is we want to get all these done by the class. So our idea is that at least one person will do each one of them, and
Yes.
some of them will be done twice.
Yes.
So that's why, there's some designation and assignment of where to go. But they all are going to be fun. There's some interesting tidbits in every one of them. So you'll have a good time, I hope, no matter what.
And even though we've labeled some of them as challenging, don't just shy away from it just because of that. That can be even more fun. So,
Yes.
Yeah.
We may
we're all
wait.
challenging in our own way.
Yeah, we may wait till the second part to assign some of the challenging ones, and but if you pick one of those, that's great. But we mainly just wanted you to know that you may have to scratch your head a little bit longer to find, to really find these faults, and your map in the end may not look, quite as complete as someone in an area that was a little bit, where the faults were a little bit better exposed. But again, it's important, even in areas where the faults are hidden for a variety of reasons, that we still make a solid effort at mapping them. And particularly for understanding probabilistic fault displacement hazard, some of these more challenging cases provide important end members for fault mapping.
Yeah, and don't force faults to be in places, just because you might be like, I don't see a single fault here. And that's okay. It just go with this sort of, remember how we've been trying to emphasize objective to interpretive. So, it's the Earth's surface. You'll see something. So just map what you see. And then remember, the fault is kind of this pretty high level of interpretation. It requires, the definition of a fault is some interface along which there's been displacement. And so that's, you have to then identify, what's been displaced. So don't force it. But I think if you guys, are systematic and patient with yourselves, you'll find some really interesting little tidbits. And then you'll be like, you know what? I think it's right here. And then all of a sudden the story comes together in a defendable way. So be patient.
So just briefly, the goal would be to pick mapping choices for yourself that avoid bias, because they're trying to find faults that you know very little about already.
For example, you may not want to pick like Parkfield.
Right. Okay. Just because you said pick the one you're interested in, but really it should be like aiming for Japan or something.
It would be better. I mean, you know, you probably haven't walked along all of Parkfield, but you have been in southern part, so you'd kind of already know where things would go. So that kind of would defeat the purpose. It'd be too easy.
Thanks.
Any more questions? Sean, did you want to ask your question?
When do you want to know our choices by?
Tomorrow evening. So then on Thursday, I'll start dividing things up and making assignments and probably get them along with the data sets very early next week.
I had a quick question about the dating of the imagery. So I know they have pre-rupture and post-rupture imagery, and on the left side there's dates, and on the right side there's like dates of the imagery available. So are we to only look, because I know like some in Google Earth, are we to only look at the dates of the imagery listed on the right, or anything before the ones on the left?
You can look at anything before. For example, for this Parkfield 2004 earthquake, I found that there was relatively high quality imagery in 2003. But if you find other imagery that you want to use, then please use it.
Okay.
Search.
But we're not supposed to really look at like post-earthquake imagery?
Correct.
Okay. And so once we do a little bit more research, is it there going to be one like main earthquake that we know happened that we're supposed to be looking before?
So for example, say you pick the Bora Peak earthquake, which is in Idaho, 1986. So not 1983. Was it 3?
Yeah, that's right.
3. Okay. So then for this, I've found that it's hard to find data before 1983. But I will either send you or point you in the direction of this, the photos from the USGS that you would want to use. And so it's not expected that you would spend really any time looking for any more data than we have here, unless some of these more recent earthquakes, Google Earth is a good reference to use.
Okay.
Does that answer your question?
Yes, thank you.
Okay, so we continue. Think of any questions. I made a brief video on my other computer showing